Hello everyone, my name is Fernando Gasca and I am a software engineer with the Curry development team. In this short video, we will go through the template matching functionality in the Curry software. Template matching is a powerful tool which can help us find signals which occur multiple times throughout a recording. We can do this by defining a template, which can be an epileptic spike or an artifact, and then use certain criteria to find how well other instances match our template. In the case of Curry, we use amplitude as well as correlation. Let's jump to Curry and see an example. We will work with the interictal EEG example data, and I will choose this spikes left and right file, which contains interictal spikes on the left and right hand side. I will now change the view of the user interface to show me the functional data, that is the EEG traces, as well as the topographical maps, which is advisable when marking spikes. I will switch to the functional data parameter pane and only apply one filtering signal processing step because I know that this file has a common average reference and this is the only step that I need to do. So the filtering will be user-defined auto, which applies a high pass and a low pass, and this is enough for this file. So after that, I can add a second processing step to my processing chain, which will be template matching. So now I can go ahead and define my template, but first I need to choose which channel or channels I want to use. In this page of data, I can already see several spikes. So I will take the very first one, just place my cursor and see that this spike shows some negativity on the left side. And I will choose the template channels control to choose which will be my template channels. I can either choose a channel, a group of channels, or use these options such as best, opposite, best 3, best 5. The best channel will be the one with the best signal to noise ratio in this latency. So I can see that the template matching auto selection of the best template channel chose the F7 channel, which is being highlighted, and I can already see a template of this interictal spike. I can change the length of this template by adjusting this start and end times. So I will decrease this time to make the template longer, and it is important to say that the template matching algorithm benefits from templates which have several zero crossings. The dotted line in the plot corresponds to the zero line. So we can see that in this template that we are defining, we have indeed several zero crossings, which is good. And now that I have already defined my template, I can just press the scan button, which will go through the data. After that, I can click the review button and see that the template matching is already giving me 9 matches, which correspond to those spikes which fulfill the criteria that are specified in the template matching interface. That is an amplitude of at least 70% of the template and a correlation of 80% or higher with our template. We can take a look at the results. The matches show an annotation which corresponds to the scores of the two criteria. That is, the first number corresponds to the amplitude and the second corresponds to the correlation of this particular match with the template. And at any point, we can average these results by just pressing the averaging button in the events epochs. Now I can display a butterfly plot and switch back to topography maps. So in this video, we show how to work with template matching in an example where we took an epileptic spike and looked for similar matches throughout our file. We found 9 matches and created an average of them. With this, I conclude this video. Thank you for your attention.